Our next learning target is about Vesper theory. And here are the bullets that we're going to be looking at. So we're going to analyze the molecular compound using Vesper theory. So the first thing we're going to do is talk about our Lewis structures. Now remember that these are dot diagrams. So if we have a chlorine molecule, which is Cl2, that means two chlorines react together to form one bonded compound. Notice that they share those two electrons. Okay? So when you draw this, instead of drawing all of these dots, we represent a pair of dots by a single line. So this line here represents 2 electrons. This line, 2 electrons. Okay, so you see how that works. Each line is 2 electrons. Alright, so it's a pair. So all of those are 2 electrons that are being shared between each of those atoms. So you need to pause and copy some steps down. The first thing you're going to do is find the total number of valence electrons. We're going to use the periodic table for that. We're going to choose the central atom. It's always the least electronegative. It's always your single atom. Okay? And we're going to arrange the other atoms around our central atom. Then we're going to arrange all the electrons so that the atoms have a full octet. Now remember that an octet is 8. Now if you have extra electrons that are left over, you're going to add them to the central atom. And if you run out of electrons before you fill up all the octets, you're going to create double or triple bonds. So let's look at a few of those. Alright, to calculate our valence electrons, here's what we do. Our formula here is CF4. So we look at our subscripts. Okay, remember that there's a 1 there. So that goes here with the carbon. The 4 here goes here with the fluorine. There's where those numbers come from. The valence electrons come from the periodic table. Alright, remember 1, 2, skip a few, 3 through 8. So make sure your periodic table is labeled. So carbon is in column 14. Those all have 4 valence electrons. Fluorine is in column 17. Those all have 7 valence electrons. So then we multiply, so we get 4 valence electrons from carbon, 28 from fluorine, for a total of 32 valence electrons. So now we're going to follow the rest of our steps. Our central atom is carbon, alright, because if our formula is CF4, carbon is the single atom. Then we're going to arrange the atoms around our central atom. So we're going to put our 4 fluorines around there. Now remember that each of these lines is 2 electrons. Okay? And then we're going to add the rest of our electrons so that we can get each atom to have 8. So that's your goal, is to get each atom with 8 electrons. So we did 2, 4, 6, 8 electrons in our bonds. So 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Okay, so we used all 32 of our valence electrons. Now we need to double check. Does everybody have 8? There are 8 around this fluorine, 8 around this fluorine, 8 around this fluorine, and 8 around this fluorine. And carbon has 8. So everybody is happy. This is the Lewis structure for CF4. Alright, let's look at another example. Oh, first of all, we need to know these exceptions, so write these down. Hydrogen's happy with 2, beryllium is happy with 4, aluminum and boron are both happy with 6. They don't need 8. Alright, so know these exceptions. Alright, if we look at water, our subscripts here, we have 2 hydrogens and we have 1 oxygen. That's where those numbers come from. From the periodic table, hydrogen's in the first column, so it has 1 valence electron. Oxygen is in the 16th column, so it has 6 valence electrons. So we get a total, 2 plus 6, of 8 valence electrons. So then we're going to choose our central atom. So oxygen is our single element. We're going to attach our hydrogens. Okay? Now, in bonding, we use 2, 4 electrons. Okay? Now I'm going to erase those. I don't want them to confuse us. Alright, so hydrogens are happy with 2 valence electrons. So we can't add any more to the hydrogen. So I have extra electrons. So I am going to put those on the oxygen. Now I know from experience this is where they're going to go, and you're going to learn that too. Alright, so now we have to count. We have 2, 4, 6, 8 electrons around the oxygen. He's happy. And each hydrogen has 2 electrons, so they're happy. So this is the Lewis structure for water. Alright, if we have boron trichloride, alright, there's 1 boron, there's 3 chlorine, 3 valence electrons because it's in column 13, 7 valence electrons because chlorine is in column 17. So we have a total of 24 valence electrons. So now we got to choose our central atom. So if our formula is BCl3, then boron will be our central atom, and we will attach our 3 chlorines. Now again, boron is one of the exceptions. It is happy with 6, so 2, 4, 6 in the bonds. So now let's start adding. We have a total of 24 valence electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Now double check, is everybody happy? The chlorines all have 8. The boron is happy with 6. So this is the Lewis structure for boron trichloride. Now when you have an ion, I know this is silly, when you have an ion, you have to adjust your valence electrons. So if you have a negative ion, you're going to add electrons. Remember, that's how negative ions are formed. A positive ion, you're going to subtract electrons. Then we're going to put the whole structure in brackets and write the charge outside the brackets. So let's look at an ion. Oops, went too far. Nitrate. Nitrate is NO3. So we have 1 nitrogen, 3 oxygen. We look at our periodic table. We see that nitrogen is in column 15, so it has 5 valence electrons. Oxygen is in column 16, so it has 6. Now, when we multiply those out, we see that we get 23 electrons. Now, because this is a negative ion, we add 1 electron, and we get a total of 24 valence electrons. So now we're going to choose, let me just jot these down so we'll remember. We're going to choose our central atom, so it's going to be nitrogen. We're going to situate our oxygens around our nitrogen. So we've done 2, 4, 6 electrons in the bonds. So we get 8, 10, and 12, 14, 16, 18, 20, 22, 24. Now, I strongly recommend that you use a pencil when you do these kinds of problems, okay, because you're going to have to change some stuff. So if we look here, the oxygens all have 8, but our nitrogen does not. So we have run out of electrons. So if you go back to your steps, it tells you what to do when you run out of electrons. You have to create a double or triple bond. So what we have to do is erase some of our electrons, and we have to create a double bond. So what that does is there's still 8 electrons around this oxygen, but now there's also 8 electrons around the nitrogen, because each bond here represents 2. So a double bond is actually 4 electrons. A triple bond would be 6 electrons. And it doesn't matter which oxygen you put that double bond on. Okay, that doesn't matter. Now, because this is an ion, we have to put the whole thing in brackets and put the charge on the outside.